Okay, let's unpack this job interviews. For so long, they've been this very human dance, right? You polish the resume, get the call, then it's face-to-face. But now, well, you might be facing something else too. AI, artificial intelligence. It's definitely growing.
That's absolutely right. Yeah, AI isn't just some idea for the future anymore. It's really actively changing how people get ready for interviews, how companies look at candidates, and, even how career coaches help their clients. For this deep dive, we've looked at some really interesting stuff, how AI is shaking things up. We'll get into the core AI ideas behind these changes and hopefully give you a practical sense of what it means.
Exactly. Our mission here really is to give you a clear picture of this whole AI-enhanced interview world. We want to skip the super technical jargon, give you insights you can actually use, whether you're looking for a job, hiring people, or maybe just curious about how fast this is all moving. We've got articles on AI's current role, some really smart questions to ask both for candidates and interviewers, plus the latest tools, and just how to make sense of it all.
And, to really get how AI is changing interviews, it helps us see how it's already hitting other areas. Think about healthcare. AI is helping with diagnoses, sometimes even assisting in surgeries. Finance uses it to spot weird patterns like potential fraud. And cars. Well, AI is the engine behind self-driving tech becoming a reality.
Yeah, it's weaving into so many things like retail is a great example, right? A traditional industry totally reshaped. We're seeing shopping customized based on our data, supply chains getting way more efficient behind the scenes, and customer service. More and more chatbots and automated systems. It's a real shift.
Definitely. Now, when we talk about AI in these areas, and especially for interviews, it's useful to know a couple of basic types. You often hear narrow AI, or sometimes people call it weak AI. This AI is built for specific tasks. It does them really well, but it doesn't have general intelligence. Think Siri or Alexa, or those systems recommending movies, or even facial recognition. Super useful for their specific job, but limited.
Right, specialists. They do one thing well, and that's different from general AI or strong AI. What's the big difference?
Yeah, general AI. That would be AI that could understand and learn pretty much any intellectual task a human can. Unlike narrow AI, which is focused, general AI would have broad cognitive abilities, like us. It could learn, understand, apply knowledge across different situations, even new ones. But, and this is important, general AI is still mostly theoretical. We haven't actually built it yet.
Okay, so my smart speaker knows the capital France, but it can't suddenly write a novel about it.
Got it.
Now, two terms that pop up a lot, machine learning and deep learning. Same thing. Or?
Not quite. Machine learning is, it's the broader field within AI. It's about teaching computers to learn from data without programming every single rule explicitly. Deep learning is a specific part of machine learning. It uses these things called neural networks with lots of layers. To analyze really complex data, think of it as a more advanced tool in the machine learning box. Great for tricky patterns.
Okay, so deep learning is like a supercharged machine learning, using those layered networks for tougher problems. Now, there's this concept, the bias-variance trade-off. How does that affect how well these AI models work, especially when, they're evaluating people?
The bias-variance trade-off. That's fundamental to model accuracy. Imagine an AI interviewer. High bias means it's too rigid, maybe following simple rules. It might miss good candidates who don't fit a narrow mold. That's underfitting. High variance, on the other hand, means it's too sensitive to the specific data it trained on. It might make weird judgments on new candidates based on noise. That's overfitting. So the goal is finding that sweet spot, that balance. Learn the real patterns, but don't be too rigid or too easily swayed by quirks in the training data.
Right. You don't want an AI that ignores great unconventional people, but you also don't want one picking people based on random stuff from its training. Finding the middle ground. Okay. And you mentioned a loss function. It sounds a bit technical. What is it? And how does it help train these AI interviewers?
Think of a loss function as the AI's its performance score, like a grade. It measures how far off the AI's predictions are from the actual results. So for an AI predicting if someone will be a good hire, the loss function says how often it's getting it wrong. High loss, not doing well. Low loss, getting more accurate. During training, the AI's whole goal is to minimize this loss. It adjusts itself using techniques like gradient descent. It's constantly trying to improve its grade by learning from mistakes. Common examples are mean squared error, looking at average squared differences, or cross-entropy loss, often used for categorization, like good fit, not good fit.
Okay, so it's how the AI knows if it's getting better or worse at its job. Makes sense. Now, something that's huge right now, generative AI. What is that exactly and how might it fit into interviews?
Generative AI is really fascinating. It's AI that can create new data that looks like the data it learned from. That could be text, images, music, video, all sorts of things. In the interview context, well, it's still early, but you could imagine it creating super realistic interview simulations for practice, or maybe helping interviewers generate follow-up questions based on what a candidate says. It's all about creating something new from learned patterns.
Wow, AI generating interview scenarios. Feels like we're just starting to see what's possible there. Okay, let's dig into some more technical concepts that affect how AI actually analyzes interview stuff. Decision trees. And why are things like gradient boosting and random forests considered so powerful?
Ensemble methods, right? Right. A decision tree is a fairly basic way an AI can make choices. It follows a path of questions, like branches, to reach a conclusion. Ensemble methods like gradient boosting and random forests basically amplify this. Instead of just one tree, they combine predictions from many trees. Lots of them. It's like getting opinions from a whole panel of interviewers, not just one. You get a more robust, accurate result. These methods are popular because combining models like this often really boosts predictive accuracy. It smooths out the errors of individual trees.
So like a team of AI decision makers learning together for better predictions. I like that analogy. You also mentioned optimization techniques earlier. What are those and how do they help the AI learn effectively?
Optimization techniques are the engines that drive the learning process. They're how AI models fine-tune themselves to make better predictions. Remember the loss function. Optimization techniques are the tools the AI uses to minimize that loss. Imagine the AI trying to figure out how much weight to give different skills. Optimization techniques like gradient descent, or more advanced ones like SGD or ATOM, help the AI systematically adjust those weights based on the data, gradually getting better at figuring out what matters most.
Okay, the underlying mechanics that let the AI improve its evaluations. Got it. Now, what if the data the AI learns from isn't balanced? Like way more examples of successful hires from one background. How do you handle imbalanced data sets?
That's a really critical issue. Imbalanced data can lead to biased AI better at predicting for the majority, worse for minorities. There are several techniques. One is trying to balance the data set itself. You can create artificial examples of the minority group. That's what things like SMOT do. Or you can reduce the majority group examples, called undersampling. Another way is to adjust how the AI makes decisions, maybe making it pay more attention to the minority group. And finally, using evaluation metrics that aren't just about overall accuracy, like the F1 score, which gives a more balanced view.
Right. Important steps to try and make sure AI isn't unfairly disadvantaging people. Okay, let's touch on some specific algorithms. Support vector machines, SVMs. What are they good for with interview data?
SVMs are powerful classifiers. They're good at sorting things into categories. In interviews, an SVM could classify candidates maybe likely good fit versus unlikely good fit based on skills, experience, etc. What's interesting about SVMs is they can handle complex, nonlinear relationships using something called the kernel trick. Think of it like this. Sometimes the factors for success aren't just simple lines. The kernel trick lets the SVM find patterns in a higher dimensional space, if you will. It helps find strong candidates who might not look like an obvious fit with simpler analysis.
That kernel trick sounds clever, finding hidden patterns. So SVMs help categorize in sophisticated ways. What about k-nearest neighbors, KNN? Different approach.
Yeah, KNN is more straightforward. It classifies something new based on its k closest neighbors in the training data. So for a new candidate profile, KNN looks at similar candidates in the database and sees how they did. If most of the neighbors were successful, it predicts the new candidate might be too. Simple idea. Similarity breeds similarity.
Simple, but makes sense. Okay, what if you don't have categories beforehand? That's where clustering algorithms come in, like k-means or DBS-scan.
Exactly. Clustering is for finding natural groups in data without prior labels, unsupervised learning. For interviews, you could use k-means or DBS-scan to find groups of candidates based on skills, experience, maybe even past interview performance. It helps hiring teams see what kinds of talent they're attracting, or maybe identify skill gaps. K-means might find distinct clusters, like different specializations. DBS-scan could highlight unusual outliers who don't fit common groups.
So they reveal hidden segments within the candidate pool. Could be really useful. Now, what if you have tons of data on candidates? So many variables, how do you simplify? That's where PCA comes in. Principal component analysis?
Precisely. PCA is a dimensionality reduction technique. It simplifies complex data by reducing variables while keeping the most important info. Imagine a profile with dozens of skills. PCA finds the main underlying factors that differentiate candidates, condensing the data. Makes it easier to visualize, build efficient models, and understand what really drives success in a role.
Like finding the core traits that matter and cutting through the noise? Useful. And finally in this section, regularization techniques, L1 and L2. How do they link back to that bias-variance thing?
Regularization techniques, L1 and L2, are mainly used to prevent overfitting that high variance issue. They work by adding a penalty to the loss function during training. This penalty discourages the model from relying too much on any single feature or making the feature weights too large. Keeping weights smaller makes the model simpler, less likely to just memorize the noise in the training data, which means it performs better on new, unseen data like new candidates, helps strike a better bias-variance balance.
Okay, keeps the model from getting too specific to the training data, makes it more adaptable. Helpful overview. All right, let's shift to some more advanced topics for a deeper dive. Parametric versus non-parametric models. What's the main difference?
The key thing is the assumptions they make. Parametric models assume the relationship between inputs and outputs follows a specific form, like a line or curve. They learn the parameters of that assumed form. They're often simpler, need less data, but if the assumption is wrong, they won't do well. Non-parametric models make fewer assumptions. They're more flexible, can learn more complex relationships, but they usually need a lot more data to train effectively.
So, parametric fits data to a mold. Non-parametric lets the data shape the model more. Got it. Now, natural language processing, NLP, huge area.
Yeah.
What are some basic ways AI uses language, and what are the more advanced things relevant to analyzing interviews?
Yeah, basic NLP includes things like breaking text down, finding keywords, figuring out sentiment, positive or negative tone. In interviews, that could analyze resumes or written answers. Advanced NLP gets much deeper into meaning and context, identifying named entities, job titles, companies, more nuanced sentiment, detecting sarcasm or uncertainty, understanding relationships between concepts in a conversation. These advanced methods, often using models like BERT or LSTMs, are crucial for AI tools that try to understand spoken or written interview responses more like a human would. It's not just what was said, but maybe how it was said, implications about communication style, confidence.
Amazing how AI is learning language nuances. You also mentioned linear algebra. Sounds like math class. How does that actually support AI in interviews?
Yeah, but linear algebra is really the language of AI. It gives us the math tools to represent and manipulate data. Candidate profiles, interview text, connections, and neural networks, all represented using matrices and vectors. Operations like matrix multiplication are fundamental to how many AI algorithms process information and learn. So while you don't see the equations on screen, linear algebra is the invisible foundation making it all work.
The mathematical backbone, allowing AI to process interview data. Cool connection. Now, training those deep learning models, we often hear backpropagation. What is that?
Backpropagation is the core learning algorithm for neural networks. Essentially, it's how the network figures out how to adjust its internal connections, the weights based on the errors it makes. When the network gets something wrong, backpropagation calculates how much each connection contributed to the error, and then slightly adjusts those connections to reduce the error next time. It's iterative. Predict, check error, adjust over and over, getting better.
The mechanism for learning from mistakes and improving evaluation over time. We touched on RNNs, recurrent neural networks for NLP. How are they different from LSTM's long short-term memory networks? Why does that matter for conversation?
Traditional RNNs process sequences, like words in a chat, by having a sort of memory of what came before, useful for interview flow. But they can struggle to remember things over long stretches, like forgetting the start of a long answer. LSTMs are a special type of RNN designed to fix that. They have a more complex memory system, memory cells, that lets them hold on to information for much longer. Really important for interviews, because an early answer might give context for something said later. LSTMs capture those long-range dependencies better.
So LSTMs have better long-term memory for conversations, vital for interview context, key advantage. In convolutional neural networks, CNNs, often linked to images. Any role in interviews?
Well, CNNs are primarily known for image data. They're deep neural nets, great at identifying spatial patterns. You could imagine future applications, maybe analyzing nonverbal cues in video interviews, facial expressions, body language. But that raises huge ethical questions about privacy and misinterpretation. Currently, for analyzing the actual text or speech in interviews, RNNs and LSTMs are generally more common than CNNs.
Right, primary strengths is visual, potential future use in video analysis, but big ethical flags there. Okay, switching gears. Reinforcement learning. Sounds sci-fi. How does that work in AI, and could it apply to interviewing?
Reinforcement learning is cool. An AI agent learns by doing things in an environment and getting rewards or penalties. The goal is to learn a strategy, a policy that maximizes rewards over time. Think of an AI interviewer learning which questions get the most insightful answers. Through reinforcement learning, it could try different questions, get feedback. The rewards may be based on predicting higher success later, and learn which questioning strategies work.
Like an AI interviewer learning on the job, refining techniques based on outcomes. Interesting. What about transfer learning? Reusing knowledge. How does that apply in hiring?
Transfer learning is super useful. You take a model trained on a huge data set for one task, then adapt it for a new related task where you have less data. For interviews, maybe take a massive language model trained on the whole internet, then fine-tune it specifically to understand interview language and jargon. Saves tons of time and resources compared to starting from scratch, and often works better, especially with limited specific interview data.
Efficient. Leveraging existing AI knowledge for interview tools. And finally here, recommender systems. We see them everywhere online. How could they help hiring?
Recommender systems suggesting things you might like could work in hiring too. For a job seeker, it could analyze their profile and recommend relevant jobs they missed. For recruiters, it could scan their database and suggest potential candidates for a new role, even if they haven't applied. They usually work by finding similarities between users or items based on past data.
So AI is a sophisticated matchmaker, connecting talent and opportunities. Fascinating potential. Okay, let's move into practical scenarios. How is AI used now in areas like customer support? What can that tell us about its potential in fields like interviewing?
Customer support heavily uses AI already. NLP chatbots handle routine questions 247, freeing up humans for complex stuff. Sentiment analysis flags frustrated customers for faster human help. This shows AI handling initial interactions, filtering info, even getting a sense of emotional state, all potentially relevant to early interview stages.
Makes sense. AI for initial screening, flagging key info, leaving humans for deeper conversation. What about marketing? How's AI tailoring content? Could we see similar personalization with candidates?
Oh yeah, AI is huge in marketing. Analyzing data to understand preferences, then tailoring content suggesting topics, personalizing emails, optimizing send times. Tools like GPT even help write copy. In hiring, you could see similar personalization. AI analyzing a candidate's background and the job to maybe tailor interview questions or provide personalized info about the company or role could make the experience more engaging and relevant for the candidate.
A more personalized journey for job seekers, like for customers.
Yeah.
Interesting parallel. What about fraud detection? How does machine learning do that? Could those techniques help ensure fairness in evaluating candidates?
Machine learning is key for fraud detection. It learns patterns from historical transaction data to spot anomalies or classify transactions as fraudulent or not. Techniques like anomaly detection find unusual activity. Supervised learning uses labeled data. Applying it directly to candidate evaluations may be a stretch, but the core idea. Identifying unusual patterns or inconsistencies. Potentially, AI could flag odd responses or maybe inconsistencies in an interview for a human to look closer at, carefully.
Thought-provoking. Using AI to flag anomalies for human review. Now, consider operations. Manufacturing, logistics. How does AI boost efficiency there? Lessons for the often slow hiring process.
AI drives huge gains there. Predictive maintenance uses sensor data to predict machine failures. Supply chain optimization forecasts demand. Robotics automate tasks. Real-time analysis finds bottlenecks. AI checks quality control. Hiring often gets bogged down in admin, scheduling. AI could streamline things like resume screening, interview scheduling, maybe initial assessments. This would free up recruiters to actually build relationships with top candidates.
Automating and optimizing logistics so humans can focus on the human connection. I see the parallel. Okay, shifting focus squarely to ethics. How do AI pros think about fairness and avoiding bias when building AI for hiring? This is crucial.
Absolutely critical. It involves really careful attention to the training data. Is it representative? Does it reflect existing societal biases we don't want to perpetuate? It also means using technical methods during development to detect and correct bias. And crucially, continuously monitoring the AI's performance across different demographic groups after it's deployed. Identifying and fixing disparities is an ongoing job.
An ongoing process. Data curation, technical fixes, continuous monitoring for fairness. Okay, now let's dive into the core. The AI revolution in interviewing itself. How's it changing things for candidates, interviewers, even career coaches?
It's transforming the whole landscape, really. For candidates, AI tools offer personalized prep that just wasn't widely available before. Realistic simulations, tailored questions based on the actual job description, detailed feedback on answers, even delivery style.
We heard some names. Can you give specific examples of these AI helpers candidates are using?
Sure. There's interviewing.io, anonymous mock technical interviews, Cramp, peer practice. Richard McMunn's interview coach tailors questions. LeetCode Wizard helps with coding prep. Teal's AI interview practice uses job descriptions for mock interviews and gives analytics. Udly AI interview coach focuses on speaking patterns. Google's interview warm-up helps practice common questions. Quite a few options emerging.
A real variety. And it's not just candidates. How are career coaches leveraging AI?
Coaches are finding AI really valuable. They can use these practice platforms to give clients unlimited reps, get objective feedback to discuss. Some AI tools can help coaches generate tailored questions for clients or analyze communication style for more targeted guidance.
So AI helps coaches give more personalized, data-driven support. But even with all this AI, the human connection, judgment, that's still vital, right?
Absolutely essential. AI can boost efficiency, provide insights, but the human element is critical. Interviewers need to use AI to augment judgment, not replace it. Assessing cultural fit, nuanced skills, potential, that takes human interaction. Intuition. The goal is balance. AI streamlines and informs, humans bring expertise and empathy.
A partnership. AI analytics, human insight. Makes sense. Now, for candidates navigating this, what forward-thinking questions should they ask employers about their AI use?
Candidates can really show awareness by asking things like, how does your company use AI now to improve products or services? Or how is AI changing workflows on your teams? Maybe ask about adopting new tech. How does the organization evaluate and integrate new AI tools? Questions like these show you're thinking about the tech landscape and the company's strategy.
Great examples. Shows you're thinking bigger picture. What about understanding the culture around adopting AI?
Good point. Maybe ask, how do you support employees in learning new tech and adapting to AI changes? Or, can you describe how teams collaborate when integrating AI tools? These get at how the company handles change and supports its people in this evolving environment.
Yeah, it gets to the heart of managing change and employee support. Now, flip side. What forward-thinking questions should interviewers ask candidates about AI readiness?
Interviewers can gauge adaptability. Tell me about learning a new technology quickly. Your approach. What did you learn? Check. Comfort with AI. Any experience with AI tool or systems? Benefits, challenges, for problem solving. How would you approach a task that AI could potentially make more efficient? These help assess a candidate's willingness and ability to work with new technologies, not just their technical skills alone.
Insightful. Goes beyond skills to mindset and approach. We mentioned some specific AI prep tools. Let's highlight a few innovative ones candidates might find helpful.
Definitely. Interview Copilot, or Interviews Chat, is interesting. Real-time AI assistant during practice suggests technical behavioral answers, smart follow-ups. Huru AI Video Coach, feedback on answers and body language, vocal delivery. Converts job postings to interview questions. AMA Interview aims for quick, easy practice, instant feedback. Final Round AI offers real-time guidance and analytics. Teal's AI interview practice gives deep performance analytics on practice sessions, and Experiment Practice blends peer-to-peer practice with AI feedback, good for roles needing tech and soft skills.
A diverse range of tools helping candidates prep in new ways. Great examples. Now, how is AI specifically impacting career coaches beyond just using these practice platforms?
Well, AI offers coaches new ways to enhance services. They can use AI to help clients identify potential career paths based on skills experience. AI can help analyze job market trends, pinpoint in-demand skills. And as we said, AI practice platforms provide mock interviews and feedback for coaches and clients to analyze together. Some tools even help with resume optimization, writing cover letters.
So AI is a research assistant and practice partner for coaches, enabling more comprehensive support. Okay, as we wrap up, let's revisit that crucial point, maintaining the human element. Final thoughts on how candidates, interviewers, coaches can keep that connection central.
Yeah, it's key. For candidates, use AI tools to prep, but be authentic in the real interview. Showcase your unique self. For interviewers, use AI to augment, not replace. Prioritize genuine connection. Assess those uniquely human qualities. For coaches, guide clients on using AI effectively, but stress developing interpersonal skills and authentic presentation. Ultimately, the goal is leveraging AI for efficiency and data, but never forgetting that hiring is fundamentally about people connecting with people.
Well said. Enhance, don't replace the human element. And that brings us to the end of this deep dive. It's really clear AI is having a big and growing impact on job interviews.
Absolutely. Exciting opportunities, but also important things to consider for everyone involved.
Yeah. So to leave you with a final thought to chew on, as AI gets more sophisticated in interviews, how will that ultimately change how we even understand and evaluate talent? What are the long-term effects going to be on that human-to-human connection in the vital process of finding the right person for the right job? Definitely something to ponder as this tech keeps evolving.